So here we have found things about lengths, angles, and stuff like that. One important concept that we haven't understood yet in terms of vectors is area. So let's say that we want to find the area of this pentagon. Well, how do we compute that using vectors? Can we do it using vectors? Yes, we can, and that's going to be the goal, but how? So the first thing we should do is probably simplify the problem. We don't actually need to bother with pentagons. All we need to know are triangles. Because, for example, you can cut that into 3 triangles and then sum the areas of the triangles. OK, so perhaps easier, what's the area of a triangle? So let's start with a triangle in the plane. And, well, then we need 2 vectors to describe it, say A and B here. How do we find the area of a triangle? Well, we all know base times height over 2. So what's the base? What's the height? Well, so the area of this triangle is going to be 1/2 of the base is going to be the length of A, and the height, well, if you call theta this angle, then this is length B sine theta. Now, that looks a lot like the formula we had there, except for one little catch. This is a sine instead of a cosine. How do we deal with that? Well, what we could do is first find the cosine of the angle. We know how to find the cosine of the angle using dot product. Then solve for sine using sine square plus cosine square equals 1. And then plug that back into here. Well, that works, but it's kind of a very complicated way of doing it. So there's an easier way. Okay, and that's going to be determinants. But let me explain how we get to that, maybe still doing elementary geometry and dot products first.